Hello everyone, welcome back. In this video, we are going to learn about how we can use the AI perception system to make the AI see the player. Once the AI sees the player, we can make the AI stop patrolling and chase the player. But you might be wondering, what is the AI perception system? The AI perception system is a tool you can use within the AI framework which provides sensory data for an AI. This provides a way for pawns to receive data from the environment, such as where noises are coming from, if the AI was damaged by something, or if the AI sees something. This is accomplished with the AI perception component, which acts as a stimuli listener and gathers registered stimuli sources. When a stimuli source is registered, the event onPerception_updated is called, which you can use to fire off new blueprint scripts or update variables that are used to validate branches in a behavior tree. So let's get started. Let's open up the AI folder and let's go to the AI controller. And now what we can do is add a component, and we can add the AI perception component. Okay, once you've added the AI perception component, you can see here under AI perception, we have our senses config. And here we'll have a few options. Let's select the AI sight config. Okay, now expand that out. And here we have a few variables that we can adjust. This is the sight radius. So this is the maximum sight distance to a target. We have lose sight radius. This is the maximum lose sight distance. We have peripheral vision half degrees angle. This is just a peripheral vision angle. And we can adjust these variables as we would like. Okay, so what we can do now is let's add an onPerception_updated event. So go ahead and select the plus icon for that one. What we can do is we can create a new function. We'll call this one update perception. Okay, and let's add a new variable. Let's make this an actor. And this will be an array. And this will be perceived actors. And now let's go for each loop. Okay, and now we need to make sure that the perceived actor is the player character. Well, there's a couple different ways that we could do that. We could ask to combat character, combat player character, and if we cast a combat player character, then we will know that we have perceived the player character. However, this isn't a good way to do that, as this will create a hard reference to the player character, and we really don't need a hard reference to the combat player character inside the AI. And if you don't know what a hard reference is, you can go ahead and select all and save all. And you can select reference viewer. And as you can see here, we have the combat player character as a hard reference to the AI controller. And it is okay to have our master AI as a hard reference to our AI controller because it would make sense that these would depend on each other. But we do not want to create extra dependencies to our AI system. So this would basically create a dependency to the combat player. What we can do is just remove this cast, compile and save, and let's go view the reference viewer again, and that should be gone. And as you can see, that hard reference is now gone. And so what we can do instead is, let's go to blueprints, combat player character, and actually you could use a gameplay tag for this. So let's go ahead and do that. So to blueprints, interfaces, and let's create a new interface. Now you would go through this process a lot differently if you had access to C++, but we are using Blueprint only for this course, so we will have to create a system that checks gameplay tags for Blueprint only. So let's go to blueprints, let's select blueprint interface. We'll call this one gameplay tag blueprint interface. Okay, let's create a function, get owned gameplay tags. Okay, and this one is simply going to return a gameplay tag container. Okay, let's create another one. And this one will be, and this is similar to the one that's built into the engine by default. And so there's a lot of options built into the engine. We have has all matching gameplay tags, has any matching gameplay tags, and has matching gameplay tag. We're going to need this one. However, we can't use this as this is only usable in C++. Since this course is blueprint only, we will have to create our own version of this function. So we'll call this one has matching gameplay tag. And this will return a Boolean. And the input will be a gameplay tag. And we'll call this input tag to check. Okay, compile and save. And if you want, you can add the other functions, but I'm not going to need those right now, so I'm not going to add them. Okay, let's actually go ahead and add both of these to a category gameplay tags. Okay, there we go. Now let's go to the combat player character. Here we can add gameplay tag blueprint interface. And here under gameplay tags, we can get owned gameplay tags. And let's go ahead and promote this to a variable. And we can call this one owned tags. Or owned gameplay tags. Okay. And we'll add this to a category gameplay tags. And we can make this editable. Okay, now open has matching gameplay tag and has tag. We'll plug that in there. Okay, and now what we can do is we can add a new gameplay tag, make this one character.player. Go. And now we can go back to our AI controller. We can check has matching gameplay tag. Okay, and there's going to be two. We need to hover our mouse over it, and we need to call the one that says target is gameplay tag blueprint interface. So call that version. Once you do that, we need to check is it equal to character.player. And if it is, so we need to update a variable in the Blackboard. So to do that, let's go to Blueprints, AI, Blackboard base, and let's create a new key. This we have type object. This will be target. Okay, and so the base class of the key type will be actor. Go ahead and save. And now let's go back to the AI controller. Let's get Blackboard. And from the Blackboard, we need to set value as object. And for the key name, we need to make literal name. The name will be target. And make sure that this is spelled exactly the same as it is here, because that is important. And for the object value, we can just route this to a local variable and call it L_sensed_actor. Okay, and we will set L_sensed_actor as the object value here. And if it is false, then we can set it to nothing. Okay. And now we can call update perception here. Okay, now let's go to our behavior tree. And let's go ahead and use a selector now. A selector will run from left to right, and it will stop executing once one of their children succeeds. So what we need to do is move this over here to the right, and let's create a new node. Let's add a sequence, and this will be chase player. And we need to add a decorator to this. And the decorator will just add a condition, which will determine if the sequence will run or not. So we need to add a Blackboard decorator. For the observer aborts, we need to select self. So it will abort self if the condition fails. Okay, and the notify observer will be on result change. And the Blackboard key will be target. So if the target is set, then we can chase the player. If it is not set, then we patrol. So if we're chasing the player, let's first set movement speed. We can set that to 400, that'll be fine. And then after that, we simply need to add a move to node. And we will move to the target actor. And the exceptions radius could be something like 150. Or 100, we could try that instead. Okay, let's see what happens now. So our AI is patrolling. Let's let the AI see us. The AI is not following us. Let's see here what the issue is. Let's select the AI perception. And one thing that we need to remember to do is do detection by affiliation. This is detect enemies, detect neutrals, and detect friendlies. And we need to set all of these to true. Okay, now let's try again. Okay, yeah, now he sees us and he's chasing us. But it's too easy for the AI to see the player. As you can see, he can already see the player. So let's go ahead and update the peripheral vision to about 45. And let's see how that works. Okay, that's a lot better. Now once I get within the AI sight range, the AI can now see us. Okay, and now let's see what happens whenever we go out of the AI sight. So now he's chasing us. Let's run away to where he cannot see us, and let's see what happens. See if he is still chasing us. Yes, he still chases us. And with this, the AI would probably chase us forever. And we don't want that. So let's go ahead and adjust a variable here. Let's adjust the auto success range from last seen location. Basically, this is a success range from last seen location. So if the target goes out of sight, it would be the distance from the last location that the AI saw the target. So the AI can still sense the target even if the target is out of sight, so long as the target is within this range. I'm going to set this to something like 2500. Compile and save, and let's see if the AI will see me. But as you can see, even though the AI sees me, he's not going to chase me until he gets to his next patrol location. We can adjust that here soon, but for now, I'm just going to test this out. Okay, yep, he should follow me here. I'm going to wait. Okay, now I'm going to run away as quickly as I can. And let's see if that worked. He is still chasing me. The distance might be a little bit too high. The distance is a bit too high. Just for testing purposes, let's set that to 500. But in order to fix that, what we can do is, let's get our AI perception component. Let's get actor's perception. Okay, and this will be for the sensed actor. And we can plug the sensed actor into this one as well. And here for info, we can break. And here for last sense stimuli, we can just get a copy. And we can promote this to a local variable, call it L underscore AI stimulus. And now get the AI stimulus, and we need to break it and check is successfully sensed true. Before we check this and do any of this, we need to check was successfully sensed. That is true, we continue there. If that is false, then let's remove this from here and add this here. Okay. To be able to test this better, what we can do is we can set his speed to be a little bit slower, so something like 300. That way we can more easily get away from him. We need to get him out of get to where he can't see us, and he should return to his patrol. Okay, nope, not yet. So let's get him in the corner here. Now let's run away as quickly as we can. Hide over here. Let's see if he will go back to his patrol. Okay, yeah, he has gone back to his patrol, as you can see. So that is working exactly as it's supposed to. Okay, now let's add damage sense. So damage sense would be the character cannot see me yet, and I attack him. As you can see, he still cannot see me, even though I have attacked him and caused damage. So to fix that, let's go to the AI perception, and let's add a new sense config. This will be AI damage sense config. Okay, so now that we've done that, we need to go to Blueprints, AI, Master AI, and let's go to the damage event. Let's make some room. Okay, here we can call report damage event. Okay, and the damaged actor is going to be self. And the instigator is going to be from this, it'll be instigated by. And the damage amount will be the damage. The event location will be the hit location. We don't need a tag. And we can add a hit location as well. Okay, there we go. Compile and save. Okay, and after we've done that, let's go back to the AI controller. And what we need to do now is, instead of calling get at index 0, we need to do a for each loop. And we can go ahead and delete that now. And here in the array index, we need to add a switch node. Okay, we need to add 0 and 1. Okay, and what are these indexes? Well, if we select the AI perception, we can see index 0 is sight, and index 1 is damage. So this will be the sight. Then we can just copy and paste the same code here for the damage. Okay, now compile and save. Okay, and so after implementing multiple stimuli here, you may notice an issue where go to the AI and the AI will not see us. And the reason for that issue is that we actually don't need to set this to nothing if damage is not successfully sensed. So let's go ahead and delete that and see if the issue is not resolved. As you can see, now he can see the player. Let's wait until he starts patrolling, and let's let the character see us. And as you can see, until he gets to his next patrol point, he won't start chasing the player. So what we can do for that is, let's add a blackboard condition here. We'll check, the observer aborts will be self, and we'll check is target not set. So the character can only patrol if target is not set. Let's try that out and see if it works. Let's let the character see us. Okay. Yeah, but as soon as we get out of sight, he will start patrolling. And I believe the reason why that is because the distance here is too small for the auto success range. Let's set that to something like 2,500. Let's see if that works. Okay, he's seen us. Let's get around. Okay, yeah, he turns around and follows us. And that's working pretty good. Let's run away pretty far to where he cannot see us. Okay, so we're still within the success range, so he still follows us. It's a little bit far, so let's set that to 1,000. It's a little bit far for this small map anyway. You may want it to be 2,500 for your game, depending on the size of your maps. Okay, now he should go back to his patrol, and there he goes. Okay, let's see if damage sense is working now. Let's hit the character. Okay, damage sense is not working. So in order to figure out what's going on, let's go to the Master AI. Let's check this out and see if we did everything correctly. Damage actor is self, the instigator is, and oh, I see the issue here. So we have the instigated by plugged in here, which in this case would be the player controller. But what we need as the instigator for this damage would be the controlled pawn. So plug that in. Because we're updating the target as a controlled pawn and checking the gameplay tag. The gameplay tag will not be present if we check the player controller. Okay, everything is working pretty good now. Okay, I think this is a good stopping point for this video. Thanks for watching. In this video, we have learned how we can use the AI perception system to make the AI see the player. We have implemented functionality to make the AI stop patrolling and chase the player once the AI sees the player. In the next video, we are going to implement combat mechanics into our AI.